In order to understand harmonic motion, which essentially is a fancy way of saying repeated motion, so that would be things like a pendulum or waves, or imagine, the orbit of the Earth around the sun. To some degree, that is a repeated kind of cyclical motion. Any of these, we need to be able to understand the two terms frequency and period in order to understand exactly what's going on here. So in terms of the frequency, well, frequent means, how often something happens. So a little more technically, the frequency is the number of complete cycles occurring every 1 second. So if you're watching some event happen and you count one Mississippi, however many complete cycles or whatever fraction of a complete cycle has occurred, that's what we call the frequency. And we measure that in hertz. Okay, so you've probably heard that term before. If you hear 4 hertz, that means every second 4 cycles are happening. The period is actually the opposite. It's the number of seconds required to complete one full cycle. So for the frequency, you're going to have your stopwatch, you're going to time 1 second, and then you're going to measure how many cycles have occurred. The period is the opposite. You're going to start your stopwatch, you're just going to wait until one full cycle occurs, then you're going to stop and you're going to determine how much time that took. So one of the things I want you to focus on here is that the frequency is kind of measured per second, whereas the period is measured per cycle. So the frequency is in reference to the amount of cycles in 1 second, and the period is a measure of the amount of time required for one cycle. So frequency per second, period is really per cycle. That kind of helps differentiate those two. If we want to calculate them, we can kind of put those sentences into an equation form. The frequency, which we represent with a lowercase f, is the cycles per second. So the cycles divided by the time. The period is the reverse. It's the time taken to complete one cycle. So you take the amount of time divided by the number of cycles that occur in that time, and that will give you your period. One thing that I do want to note, those are inverses. So the frequency is the cycles divided by the time, and the period is the time divided by the cycles. So because they're direct inverses, we can literally say that the frequency is the inverse of the period, and the period is the inverse of the frequency. So there's no such thing as only having one of those. If you're given the frequency, you already have the period because you can take the inverse of that frequency, and vice versa. If you know the period of the motion, you can take the inverse to find the frequency. So there's no such thing as only knowing one without the other. You can always use one, take its inverse, and that will always give you the other. That's very important. It will save you a ton of time in a lot of these math or computational based problems. All right, so let's look at an example here and we can see how we can kind of calculate these. So let's say someone is on a swing and they complete 12 full there and back cycles. So one cycle is not just there to the other side, it's there and back. So 12 complete cycles over the course of 48 seconds. So if we want to find the period, we know that the period is the time it takes divided by the number of cycles. So the total time was 48 seconds, and in that time we completed 12 cycles. So the period of this motion was 4 seconds. That means it takes 4 seconds to complete one full cycle. If I want to find the frequency, I can do the reverse. The cycles divided by the time. So the cycles is 12 in this case. The time was 48. So we say that the frequency is a quarter, or 0.25 hertz. Some people watching this may realize that I didn't have to do that entire equation. Once I found one, I could also quite simply just take the inverses. So if I knew the period was 4 seconds, the inverse of 4 is 0.25, which, as we see above, was the frequency. Or if I had found the frequency first and discovered that was 0.25 hertz, I could take the inverse of that, which gives me 4, which is in fact the period. So like I said, once you have one, you always have the other. You can use the equations. You can use the inverse relationship. Either one will get you the right answers.